नमस्कार, मैं हूँ कलानिधि राम प्रसाद. Today we will be learning about thick web switch point layout. So here you can see a layout diagram which is of a thick web switch with a P clamp. Especially we will be discussing about thick web switch with P clamp. Previously, as you have seen here, the rods ground connections were connected to web. Because of that, many problems were faced by SNT staff, especially track circuit failure, maintenance problems because of rods and other such things. Now the same has been changed, and a P clamp is being provided, which is very much helpful in maintaining the point machine correctly. Basically, there are two types of point machines: low stroke, which is 143 mm, and high stroke, which is 220 mm. This is 220 mm is used for thick web switch. Low stroke 143 mm is for the conventional point machine that was being used till date. This this is provided with additional arrangement of locking. The TWS is provided with additional arrangement of locking, which is called clamp type locking, which is a direct locking. The old conventional type point machine was having only indirect locking, but TWS switch is having two types of lockings. They are direct locking and indirect locking. Direct locking is at the point, at the at the stock rail and tongue rail, while indirect locking is inside the point machine. What are the main parts in a clamp lock TWS switch? You can see they are locking bars, left hand and right hand. This is a locking bar, or you can also call it as a drive rod also, which is having insulations also. So it will be in two parts, left hand, right hand. Then you have insulation plates provided. A locking washer is available. Next, locking arms are available inside. These are the locking arms that are provided here. There is a stopper here. This is a stopper, and a drive leg which you cannot see, that is connecting between the point and the locking bar. Coming to the locking arm assembly, it consists of an LH and RH arms. What is its main function? It is to lock and unlock the clamp. I have told you it is direct locking. In the direct locking, we use this setup. It is attached with the stock rail with the help of a bracket and to lock the bars with a guide. Before going further, let us just go through the differences between the conventional 143 mm point machine and the 220 mm TWS point machine. If you take the stroke, the old point machine was 143 mm and the new point machine is 220 mm. What is the stroke? It is the distance traveled by the throw slide inside the point machine. That is uh, called the stroke of the point machine. Coming to locking, the conventional type has only indirect locking, while TW is having direct and indirect locking, two types of lockings. Hence, the safety is enhanced in TWS point machine. Current consumption, it is generally less than or equal to 4.5 amps in normal working, while for TWS it is less than or equal to 5.5 amps. The obstruction current is same in both 1.5 to 2 times of the normal working current. The opening between stock rail and tongue rail is 115 mm plus or minus 3, while in TWS it is 160 mm plus or minus 3. Coming to the locking, provides indirect locking in point machine between tongue rail and stock rail. So as we have already discussed, it is having only one type of locking, that is indirect locking inside the point machine, while thick web switch has two types of lockings, Inside is indirect locking, and at the tongue rail it is direct locking. Stretcher bars. In 143 mm, there are Williams stretcher bars, 4 numbers are provided, while in 220 mm, there are no stretcher bars. Instead, on SSD is provided at the 13th or 14th sleeper, depending on the layout. 1 in 12, it is provided at 13th sleeper, and 1 in 16, it is provided at 14th sleeper. Tongue rails are dependent on each other. As I have told, once Williams structures are provided, tongue rails are dependent. Both tongue rails move together. But in TWS, tongue rails are independent of each other. They will move separately, not together. In obstruction test, it is almost the same both in 143 and 220 mm. The only difference here is when you keep 5 mm wedge piece, the point cannot get locked. Not only indirect but also direct locking. दोनों में it should not be locked. Insulations. Here insulations are provided at P clamp in one normal conventional point machine. It is provided P clamp, throw rod lugs, Williams structure lugs, and gauge type plates. While in TWA it is provided at P clamp, throw rod joints, gauge type plates. Again, if it is not provided with P clamp, the number of insulations are more compared to the point with P clamp. If there are no, if there is no P clamp, the insulation is provided between the slide and the ground connection. There were many failures because of this. The insulations were getting damaged. Hence, the system is now not being used. We are providing P clamp for all the point machines. Now, internal point machine, if you go to the point machine internally, what is the major difference? The rack and pinion arrangement that is provided in conventional will have 5 bar 6 teeth and notches. Similarly, if you go for TWS, the teeth and notches will be 7 and 8. That is the major difference when you come to a point machine internal. That is, rack and pinion arrangement will be different compared to 143 mm. Otherwise, almost all are same. The motor point used is same, but the thickness of the slides may vary a little. What are the important features of thick web switch? So, as per standards of interlocking, for standard 4, if you are going for standard 4, the use of clamp type point machine is desirable. Hence, Railway Board has taken a decision that we shall go for thick web switch wherever it is being provided and going for standard 4 interlocking for enhanced safety. The stock rail and tongue rail switches are physically locked by means of a clamp. This is called a direct locking. So this is another important feature in thick web switch. This locking is in addition to the locking of the switches inside the point machine, inside the conventional point machine. So two types of lockings are, that is the main and important feature when you talk about TWS. Now this point machine is fixed on point layout with thick web tongue rail. It has an opening of 160 mm compared to 150 mm in the conventional point. This opening is required to adjust all the lockings. Direct locking is also now required, hence 160 mm is provided. Next, it facilitates about 60 mm opening at the junction of railhead. JOH, it is the place where we are providing SST, where 60 mm is the opening of the stock of the tongue rail, which is in open condition. Because of that, repeated striking of inner face of the wheel. Here, repeated striking of inner face of the wheel on open switch tongue rail at JOH. So, point open switch. Here we are talking about open switch, not closed switch. With the open switch tongue rail will not be hit by the wheels. When the train is traveling at high speed of 160 kilometers, let us say 140, 160, there will be lateral movement of the train, and the wheel is likely to hit the tongue rail. Because of that, our point indication may fail. This is to, by this we are avoiding, because the opening is 160 mm, the wheel, inner face of the wheel will not touch the tongue rail of the open switch, and hence point failures are minimized. While in conventional switches, the opening is comparatively less, and chances of flashing are more. Now, both tongue rails are independent of each other in thick web switch. There are no stretcher bars. SSD is provided in place of Williams structures, while this point has a stroke of 220 mm, which is necessary to meet direct and indirect locking and unlocking of the point machine. How the distribution of 220 mm stroke occurs? You see, when the point machine movement starts, the first six total is 220 mm. Total movement is 220 mm. How that is distributed? The first 60 mm. Here only open tongue rail will move. It will move for 60 mm. While closed tongue rail only gets unlocked. There is no tongue rail movement. In closed switch, there is no tongue rail movement. Only open switch will move for 60 mm. Next 30 100 mm, both rails will move together. Both tongue rails will move together. And in the last 60 mm, the open switch, it has completed already 160 mm. Here you can see 60 and 100. Total 160 mm open switch completed. So it is now becoming closed switch. After getting closed, again it has to get locked. For that 60 mm is used. To get locked, 60 mm is used. While the close switch has moved 100 mm, now the next 60 mm is used for further move, completely opening the switch. You can just imagine my hand like this. So this is my closed switch, this is my closed switch, this is my open switch. So when the point has started, only the open switch will move, only open switch will move 60 mm. Then both together will move for 100 mm, while finally this one will move complete and close the movement. In TWS turnout, no switch stretcher bar is used, and hence switches are able to move independently. I have told you 60 mm, 100 mm, they are independently moving. This spring setting device is provided junction of railhead in lieu of stretcher bars to assist in proper setting of switch. So the switch which is provided on that up to the has to set up to 13 slippers. This is done by spring setting device. This spring setting device provides thrust on the tongue rail, that is, it pushes the tongue rail near JOI so the tongue rail bears well with the stock rail. It provides an opening of 60 mm of tongue rail, 60 mm approximately 57 plus, that is 60 mm of tongue rail at JOH, takes care of rattling of tongue rail under passage of wheels. Rattling, that is continuous touching of tongue rail with the inner edge of the wheel is avoided. Now, what are the safety checks that we need to do in this point machine? Say correspondence test. Correspondence test is done in a new installation or at every interlocking alternation or periodically once in 5 years. So what is this correspondence test? If the point at location is in normal position, it should the knob or the indication on the panel should also be normal. This is correspondence test. So when you are first installing the point machine, you need to check the exact whether a point at site is normal and at panel is also normal. Reverse at site, the panel should have reverse at panel also. Whenever there is any major interlock alterations, or at least once in 5 years, this test has to be done. Obstruction test is done once in 15 days by a technician, and any required adjustment, it has to be done by him if required. While current and measurements of current and voltage can be taken once in a month in the presence of JE or SSC. Track locking test again is done half yearly by JE or SSC. What is track locking test? It is to confirm that the point is not able to move when the track is in dropped condition. One, and once the point operation has started, when the track is in picked up condition, even if the track drops, the point should not stop. It should continue and complete its movement. That is track locking test. While out of correspondence test, it is to be done half yearly by JE or SSC, wherein out of correspondence, if it is a crossover, A end and B end points are there, both should be normal. Then only point should get normal indication at panel. Both should be reverse, then only there should be reverse indication. If one is normal then the other is reverse, there should not be any indication. This is out of correspondence test. While crank handle cutout testing, it is done once half yearly by JE or SSC, along with other tests like insulation test of point machine and cables, detection contact brake test, and cross protection wiring. This has to be checked at least once half yearly in the presence of JE bar SSC. While double cutting arrangement is available at the external wiring also. So finally, what are the advantages of TWS? If you take signaling point of view, let us first consider the signaling point of view advantages of TWS. Double locking arrangement is provided here, hence safety of train working is enhanced. We are confident that the point is locked. Both tongue rail and stock rails are locked. Both switches are checked for locking. In conventional point machine, closed switch was locked while the open switch was not locked. But here both switches, both in normal, that is in open, and closed switches are locked condition. Both tongue rails are independent, hence ease of operation. So in conventional they are rigid with Williams structures, but here they are independent. They are connected with SSD only, spring setting device, which is again not rigid. Opening at JOH is 60 mm. Hence, detection contacts didn't open when the train is moving at high speed. This is to avoid failures because of train movement and hitting of wheel with the tongue rail. So these are the advantages. So indication failures are reduced because of this. So these are some of the advantages if you take the signaling point of view. Apart from that, the number of insulations in TWS are reduced. No Williams structures are available, hence maintenance point of view, insulations are reduced and hence failures are also reduced. No chair plate bolts, hence failure due to broken bolt is reduced. Here the sleeper and stock rails, they are held by in a different method by spring loaded leaves. No chair plates are available here, hence failure due to broken bolts which are used for at chair plate bolts are reduced. Damage to tongue rail toe is nil as the tongue rail is non-overlapping. You can see that this is your stock rail, the tongue rail will just go and it will go at the bottom. It is not overlapping. I say upar nahi aayega, it will be only at the bottom. So it is non overlapping. Train wheel does not touch the tip of the tongue rail, hence damage to tongue rail is minimized. While better setting of point machine, in this it is available up to 13 sleepers due to SSD. While what are the advantages of TWS when you take engineering point of view? As near chair plate bolts, hence strength of the tongue rail is increased. Previously, chair plate bolts were there, hence strength of a stock rail, sorry, it is not tongue rail, it is stock rail is increased. Damage to tongue rail is nil as tongue rail is non-overlapping. Less maintenance of engineering staff. Maintenance compared to here is for engineering staff is less. No Williams structures and chair float bolts are available. Because of that, less maintenance for engineering staff. Burr formation of stock rail does not affect the tongue rail. Burr formation of on the stock rail. Otherwise, in conventional used to give problems, it would not release the tongue rail. Here, it will release the tongue rail. So you can see this is the bolts that we were discussing. The holes were provided here and the nut could give failures. But in thick web switch there are no such holes on the stock rail. Hence the strength of the stock rail is increased and safety is enhanced. Here we use leaf springs and wedges to hold the stock rail with the sleeper. Here you can see the arrangement provided. This is a chair plate board. This is a leaf spring, wedge, the ERC elastic rail clip, and the rails are provided on this. This is the arrangement in place of the bolt, chair plate bolt. But then there are some disadvantages also presently, which are likely to come down as time goes on. Regular lubrication is a must and hence more maintenance for S&T staff. If you don't lubricate, point will fail, and that is at least once in a week lubrication, at times even more lubrication has to be done. If point goes out of square due to train movements, arm will not release. As I have told you, there is no rigid connection between stock rail and sleepers. Hence, the stock rail movement is available and it is going out of square. Because of this, the arms are not releasing. And hence, because arms are connected to the stock rail, they are not releasing and failures are, we are getting them failures. Adjustment of lock rod and throw rod is not as easy. Here the adjustment of the throw slide or rod, whatever you call, it is not so very easy in this aspect. In conventional it was comparatively easy, but here it is not so easy. We need to adjust. If you adjust on one side, both the tongue rails will get disturbed. That is the main drawback in this one. No chair plate bolts, hence no rigid connection between sleepers and rails. Hence points go out of square. So these are some of the basic. There are still some disadvantages there, but these are the basic disadvantages of TWS. So if you have any questions, please give them in the comment section and I will be happy to answer them. Thank you.